Somewhere in a live 5G core, a service request is already in flight. It is heading toward a network function that may no longer be where the network thinks it is. That is the quiet failure mode of modern mobile cores. Not a dramatic outage, a stale address, a ghost entry, traffic that still believes in a server that has moved or left or never quite finished announcing itself. The 5G core does not run on a single box. It is a mesh of network functions, NFS, that discover each other through a registry called the NRF, the Network Repository Function. Think of the NRF as the phone book of the core. Producers register who they are. Consumers look them up. In theory, that is enough. But theory collides with a design choice that 3GPP left deliberately flexible. Between the producer and the registry, operators can place an SCP, a service communication proxy. The SCP sits in the path. It can steer, observe, and bind sessions, and that creates a problem the phone book alone cannot solve. If the SCP is going to stay useful, it cannot merely forward packets. It must know what registered, what changed, and what vanished. Registration is not merely an announcement. Someone has to preserve the information needed later. The identity card of the NF, the local references, the fact that this intermediary still belongs in the conversation. This is the story of how an SCP in models C or D stays in the loop while an NF producer registers, updates, and finally deregisters with the NRF. Four actors, three operations, one question that never quite goes away. When the network forgets, who is still holding the map? Meet the cast, because every message in this drama has a sender and a reason. First, NF01, a network function producer. It might be an AMF handling mobility, an SMF managing sessions, or any other 5G core service that needs to be found. Beside it sits NF02, another producer in the same neighborhood of the core. They are not the villains. They are the ones who must be discoverable, or the whole service mesh loses its bearings. Next, the NRF, the registry. It receives NF instance information, stores profiles, answers discovery queries, and, when asked, deletes what no longer belongs. Without the NRF, consumers have no authoritative place to learn who is alive. And between them, when the operator chooses models C or D, sits the SCP, not a second registry, a proxy in the path. Its job is continuity. Keep communication flowing, keep itself visible in that flow, and keep a local sense of which NF instances still matter. On the diagrams that engineers draw for this, the lifelines are simple: SCP, NRF, NF01, NF02. The title is blunt: 5G Core Network, NF Producer Register, Update, Deregister, with SCP in path. The elegance is in the ordering of the arrows, not in the boxes. Here is the tension. The NRF can tell the network what exists. The SCP must also know what changed, what remains reachable, and when an NF has vanished. A registry without a synchronized intermediary is a phone book that the courier never read. And in a live core, the courier is carrying real subscriber traffic. Act 1 is registration. An NF that wants to be known does not whisper into the void. It issues a hard, explicit write. The operation is a put to /nf-instances/ then the NF instance ID. In the body rides NF profile 01, the identity card. Capabilities, addresses, services offered, the coordinates a consumer will need later. This is not a casual hello. It is a claim. I exist. Here is how to reach me. Please put me in the book. In models C or D, that put is a flow-through operation with the SCP in the path. The message does not teleport from NF01 to the NRF while the proxy looks the other way. It passes where the architecture placed the intermediary. The SCP sees the registration. That is the first requirement of staying aware. Watch the sequence the way the sequence diagrams draw it. NF01 speaks. The SCP is on the line. The NRF receives the profile and records the instance. Somewhere off to the side, NF02 may already be registered or waiting its turn. proof that this is a multi-actor system, not a single handshake in isolation. Why does the Pute matter so much? Because everything that follows, discovery, updates, heartbeats, even deletion, assumes there was a moment when the network agreed on an identity. If registration is incomplete, or if the intermediary never learned the profile, later traffic becomes guesswork. The stakes of Act 1 are simple. Get the identity card into the registry, and make sure the proxy holding the path also saw the card. Seeing the profile is not enough. The SCP has to leave fingerprints. The source diagrams are explicit about this. The SCP modifies NF profile 01 as required, adding identifying information so that later communication still routes through the proxy. It retains relevant information locally. In plain language, the intermediary rewrites just enough of the identity card that the rest of the network cannot accidentally bypass it. Imagine a building directory that lists every office. Now imagine a concierge who must remain in every visitor path. If the directory only shows the office number, guests walk straight upstairs. If the concierge adds a routing note, see desk first, the path stays intentional. That is what the identifying marker does inside the NF profile. This is not vanity. In SCP models C and D, the proxy's value depends on remaining in the communication path. If producers register raw endpoints and consumers learn those endpoints directly, the SCP becomes optional furniture. Modify the profile, retain the local reference, and the architecture keeps its intended shape. Heartbeat handling follows the same principle. Keep alives and liveness signals are not side chores. They are how the registry and the pathkeeper both learn that an NF is still breathing. The SCP treats heartbeats with the same discipline as registration. Stay informed, stay in the loop, do not let liveness become a private conversation that excludes the intermediary. So registration is two victories at once. The NRF has NF profile 01. The SCP has a modified, remembered version of that truth, and a reason to believe future calls will still touch its door. But an NF profile is not frozen. Capacities change, addresses shift, services are added or withdrawn. The network underneath the identity card keeps moving. Act 2 is the update. The verb changes from put to patch. The target is the same resource, /nf-instances/nf instance ID. The body is no longer the whole card. It is NF profile 01 patch data, a surgical edit, only what changed. Again, for an SCP in models C or D, this is a flow-through operation. The patch does not sneak past the proxy. It travels the path the architecture committed to. And once more, the SCP may modify the patch data. The diagrams even label a form like SCP-NF profile 01-patch data, so that the intermediary remains in the loop after the edit lands. Picture a delivery network updating a warehouse address. If only the public website changes, drivers who cached the old gate still arrive at a locked fence. The routing system itself must receive the patch. That is the SCP's interest in NF Profile 01 patch data. Not to own the warehouse, to keep the route honest. Updates are where many systems get sloppy. Registration feels ceremonial. Deletion feels final. Patches feel like paperwork. In a 5G core, paperwork is destiny. A consumer that discovers yesterday's profile while the producer already patched today's endpoints will open sessions into the wrong place. The SCP that failed to observe or reshape the patch becomes a blind guide, so the discipline repeats. See the patch, adjust identifying fields if the path requires it, retain what local state must know. Heartbeats and other maintenance calls obey the same rule. Continuity is not a one-time configuration. It is a habit applied every time the record moves. The hardest event is not a change, it is disappearance. Act 3 opens with a delete /nf-instances/nf instance ID. No body needed. The claim is absolute. This instance should leave the book. Deregistration is invoked toward the NRF. That direction matters. The registry is the authority that must drop the entry so future discovery does not resurrect a ghost. On the sequence diagrams, the delete travels with the same architectural honesty as the put and the patch. The SCP is still in the story, but the emotional center shifts. We are no longer enriching a profile, we are erasing one. Here is the complication the source will not let you miss. After the NRF is contacted, local SCP references must be removed. The registry can forget the NF. The proxy must forget it too. If only the NRF deletes, the SCP may keep steering as if the producer still lived behind an old binding. If only the SCP forgets, Discovery might still advertise a path the intermediary no longer understands. Both sides have to let go. There is a further nuance. The NRF can inform the SCP when relevant subscription information exists, when the proxy has asked to be told about changes that matter. Notification is not magic ambient awareness. It is conditional on the relationships the SCP established. Subscriptions turn disappearance from a rumor into a signal. Think of a hospital removing a wing from its directory while security still holds badge mappings for doors that no longer open. The public book changed, the internal maps did not. Patients get lost in corridors that exist only in yesterday's access list. Deregistration in the 5G core is the coordinated demolition of both the public entry and the private shortcuts. Watch the last movement carefully because this is where continuity either completes or fails. NF01, or whichever producer is leaving, triggers deletion toward the NRF through the path the deployment uses. The NRF removes the NF instance. Then the SCP purges corresponding local references, cached profile scraps, path bindings, whatever identifying residue it kept so it could stay in the loop. On a well-drawn diagram, you can almost see the local box go empty while the registry line strikes the name. Why corresponding references? Because the SCP may serve many NFs. NF02 might still be alive. Wholesale amnesia would be as dangerous as stubborn memory. The art is selective release. Delete what belonged to the departed instance. Keep what still describes the living mesh. Subscriptions tighten the timing. If the SCP was subscribed to the right events, the NRF's notice arrives as a prompt rather than a forensic clue discovered after traffic fails. That is the difference between a controlled deregister and an outage post-mortem. The source's note is modest, but operationally it is the hinge. Relevant subscription information lets the registry tell the intermediary when the book has changed. Sensory detail helps. Imagine a control room wall of status tiles. Registration lights a tile and writes a label. A patch rewrites the label without killing the light. Delete should darken the tile and peel the label. On the NRF wall and on the SCP's side panel, a dark tile on one wall and a glowing label on the other is how cores bleed. So deregistration is not a single delete message. It is a paired act of forgetting, authorized at the registry and mirrored in the proxy that once fought to remain in the path.